In this section, we're going to learn about even and odd functions. Determining if a function is even or odd. A function is called even if for every input x, we have the case that f of x is the same as f of negative x. Even functions are symmetric about the y-axis. So let's take a moment and graph a little bit about what that means. So one of the easiest even functions to take a look at is f of x is equal to x squared. And you might want to take a moment to graph this using Desmos to get a better picture. I'm just going to sketch a picture of what that graph would look like. So that graph would look something like this. Now, what makes this an even function, notice that it's symmetric about the y-axis, meaning you could fold it on the y-axis and the left side and the right side of the graph would match up and look exactly the same. In terms of coordinates, for example, the point 2, 8 is on this graph. And notice that the point -2, 8 is also on the graph. In other words, if x was 2, and here this would mean f is -2, notice that they have the same y-coordinate. So in other words, f of x, which is 8, is the same as f of -x, which is also 8. They have the same y-coordinate. So another way of saying that is x and -x have the same y-coordinate. So again, you could graph this in Desmos and get another picture of it. Another function you could graph that's even, for example, is f of x is equal to x to the 4th. That's another example of an even function. Now let's take a look at odd functions. A function is called odd if for every input x, f of x is the same as the opposite of f of -x. And odd functions graphs are symmetric about the origin, the point 0, 0. So, for example, let's take a look at a picture. So a common odd function to look at is f of x is equal to x cubed. The graph of f of x is equal to x cubed looks like this. And again, you could graph it in Desmos to get a better picture of what the graph looks like. So let's take a look at some points on the graph. So for example, when x is equal to 2, here we have the point 2, 8. I was thinking on this one, I accidentally was thinking about the cubed function. So pardon me, we should fix this. All right. So you probably knew that when I was writing it, when you were writing the notes, that this didn't make any sense. But let me just fix it now for us. Really, this is the point 2, 4 and -2, 4. You knew that. You probably filled in your notes fine. It was me thinking about the cube function, thinking ahead. All right. So now let's take a look here. So when you have the cube functions, if x is equal to 2, the y-coordinate is 8. And if x is equal to -2, the point -2, -8 is also on the graph. So in other words, x and -x have y-coordinates that are opposites. So this is just saying in words what this says in symbols. So sometimes the symbols make sense to us. Sometimes it's nice to have the symbols translated to words. So one of the things you'll be doing in this section is, given a function, you'll be asked to determine if it's even or odd. So what you're going to be doing is you're going to be checking if this is true, or another way of saying that is you'll check if x and negative x have x, y coordinates that are opposites. If that's the case, then the function is odd. Here, if x and negative x have the same y coordinates, then you know the function's even. If neither of those cases are true, then the function is not even and it's not odd. So let's take a look at an example. Is this function f of x is equal to x cubed minus x even, odd, or neither? Investigate algebraically. Now you could investigate it strictly by graphing it. And you might do this before we start. Just take Desmos, graph this function. Ask yourself, is it symmetric over the y-axis? Do the left sides and right sides, if I folded it on the y-axis, match exactly? Or is it symmetric about the origin? If I folded it along the origin, would the pieces of the graph match up exactly? If neither of those is true, then the graph is neither even nor odd. But this specifically asks us to investigate this algebraically. And so to investigate if a function is even algebraically, the question we have to ask ourselves is, do x and negative x have the same y coordinate? Now, you have a choice. You could plug in a number for x. For many people, that's the easiest way to investigate it. So, for example, pick any value you'd like for x. So, for example, I'm just going to use 1. I'm going to let x equals 1. And so the question I have to ask myself is, do x equal 1 and x equal negative 1 have the same y coordinate? Well, let's find out. F of 1 would be equal to 1 cubed minus 1, or in other words, 1 minus 1, or 0. And f of negative 1 would be equal to negative 1 cubed minus 1. Now, negative 1 cubed is negative 1 minus 1, and that gives us negative 2. And so, do x equals 1 and x equals negative 1 have the same y coordinate? The answer to that is no. So I can say that this function is not even. Now, you don't have to plug in a number for x. You could just use x. And if you just use x, then you'll also use negative x. So f of x would be equal to x cubed minus x. Now f of negative x would be equal to negative x cubed minus x. Now if you cube a negative, the result is negative. And you can see now, if you compare these two expressions, f of x and f of negative x, this should be an x, they're not the same. And so the answer is no, it's not even. You could investigate odd in the same way. So for odd, remember the question we're asking ourselves is, do x and negative x have y coordinates that are opposites? And again, you could investigate this with a number. So you could plug in a number for x. Since I already used 1 in the first example, I'll just do that again. So if x is 1, we already know that f of x, f of 1, is equal to 0. Here, let me replace this with a 1. So what's f of negative 1? We already did that as well, I think. F of negative 1 is negative 2. So are these opposites? The answer is no. So this is not odd. You could also do it in general. F of x, we already know, is equal to x cubed minus x. And we already figured out that f of negative x is equal to negative x cubed minus x. And the question is, are these expressions opposites of each other? And the answer is no. The second terms have the same sign, so they're not opposites. So this function is not odd. So this function we were looking at, f of x equals x cubed minus x, is not odd. It's not even. So an example of a function that's neither even nor odd. All right, and now there'll be a couple for you to try.